Assure FHIR data ingestion is accurate for patients and healthcare personnel. Audit the relationships of column names and data values from EMR, EHR, HL7. With probabilistic matching along with validation of the completeness with data profiling analytic statistics. Rejecting bad and missing data as well outliers and invalid data patterns, determining human error of mechanical issues will be flagged and stored in a rejection error file prior to missing or error data being ingested into and corrupting the FHIR repository. Here we are viewing a few tables with column data possibly in error. Some of the data has nulls, zeros and spaces as an example. If these values are not permissible to be migrated into a FHIR repository, any business application or even reporting, analytic data lake or data warehouse, the complete row of data will be stored in a database or file system for further review and not corrupt the ending point of data at rest. Now we are configuring a database setup to be processed or potentially errored data by multiple tables in two different tables in a single run process. The user just clicks on the database, the tables one at a time and the columns within the tables they want to validate and send the errors to the rejection file. Now with the process complete we are viewing the error rejection file stored in a file system for others to view and repair as necessary to meet the requirements of FHIR and the healthcare sector systems. Automated data mapping using probabilistic matching for business apps and FHIR ingestion of data from EMR, EHR, HL7 data, and for any data sources to target mapping returning the most accurate and quick data mapping analysis and results. Take the mystery and guesswork out of your mapping of the migration of business applications and healthcare data ingested into your FHIR repository, with an automated processing application. In this run we see some of the actual data matched 100% and a value only matched 59%. This is useful in properly and accurately matching for mapping by the data with the source and new targets. Here we are setting up the parameters to process one or more tables in a database to run the probabilistic algorithm to determine possible matches of source to target matching by both the metadata being the column names and the actual data, all in one run process. Now with the process run and completed we can use the quick server pagination and scroll through the results and see the percentage of matches for the actual data, and now here we are able to see the probabilistic matches for the metadata, again in this case the column values of the source and target tables for accurate building of migration. Ingestion mapping. As we see the process stores the input and potential target table and column names, field types for most accurate migrations, the from and to values of data and metadata and the percentage of match. This data will remain available for collaborative use. This Spark 3.5, Java, Spring Swagger framework offers scalability, accuracy, low latency and automation for all data migration processes. We automate and encrypt HL7 and healthcare info into FHIR, allowing current HL7 applications and new FHIR apps to coexist. Added security with BDR's multi-factor authentication using Google's app, AES 256 encryption of FHIR and all data and class code that prevents hackers from reengineering code to discover secure information. We protect data for CCPA, HIPAA, GDPR and most data regulations.
Automated data mapping using probabilistic matching with secure end-to-end encryption. This Spark 3.5, Java, Spring Swagger framework offers scalability, accuracy, low latency for all data migration processes. Added security with BDR's multi-factor authentication, AES 256 encryption of FHIR, data and class codes, prevents hackers from reengineering code. We protect data for CCPA, HIPAA, GDPR and